Java Semi-Reader.
Hi there, fellow Java developers! In this video, I will show you how Java records can save you tons of boilerplate code with just one line. I will talk about how, when, and why to use them and compare to old-fashioned approaches. Java records were introduced in Java 14 as a preview feature, and they were stabilized by Java 16. As an LTS user, you might probably be aware that they are available from Java 17. Record is a new type declaration, like for example an enum. They are immutable and can replace plain old Java objects, aka POJOs, as data carriers. Let's have a look in the code. To begin with, let's create a POJO for a point class. I will need this to show you the difference between the old-fashioned approach and the record. So our point will have two parameters, actually the two coordinates. It will be x and y. So they will be private final int x and the private final int y. Of course, I need a constructor to initialize those. I would need getters to get the values of those parameters. So that's very basic class. And now we are missing three crucial methods, which are toString, and we want a nice representation of the point object. Then we need an equals and hashCode methods that are overriding the object method, and they are taking into account the x and y parameters, and they are checking if the objects are equal by comparing x and y coordinates, and the hashCode is generated also based on the parameters x and y. So this is our old-fashioned way of creating a POJO. Now I will create the point record, which will have the same functionality out of the box. Let's see. Point record. And we have here a word record. We have the name of our record, and we have to declare our parameters x and y. And for the record, we are doing it inside the parentheses. Int x and int y, the curly brackets, and that's it. Now let's check what exactly this point record has for us. I will create two instances. Point record 1, which will have the coordinates of 10 and 20, and the point record 2, which will have the coordinates, let's say 5 and 15. And I want to print in the console their parameters, and for this I'm calling the getter methods. As you can see, the IntelliJ IDEA shows me these two methods like x and y, and they are the getters. Getters in the record are named by the parameter name without the keyword get. And the same goes for the second. And let's execute the code and see what we have in our console. So we have these two values, 10, 20 and 5, 15, which are the same that we declared at the object creation. So it works. Now let's check the toString method, and I will simply print these two records one after another and see what happens. Here you have the very nice representation of the point record with the parameters defined. Now, to check their equals method, I want to create a new point record that will have the same coordinates as the first one. So we'll have point record 3, new point record with 10 and 20. Logically, they must be equal because they have the same x and the same y. Let's check it out. And I will check it with the point record 2, just to be more precise. So we have this true, as you can see here, and these 2 point records are equal because they have the same coordinates. So it works. And now the last point I want to check and show you, this is the hashCode. I will just print out the hashCode for all our 3 records here. hashCode point 2 and point 3, and check it. So you can see the hashCode for 2 point records that have the same parameters are also the same, which is an expected behavior, and it will be absolutely the same for our plain old data object. This is our basic representation of the record. Let's have a look once again. Here we have only one line that does all this job for us. And here we have almost 50, like 43 lines of code that do absolutely the same. But it's not only about the lines of code, it's also about the readability. And here we see that this class is purely data carrier. It has no additional logic, and it's not obscured by this boilerplate code. So we clearly see the purpose of this class. Once again, the public keyword, because we are using it publicly in our application, the record keyword, ensuring that we are using the type declaration record, the name of our record, and in parentheses we have to declare the parameters that have to be initialized as fields in our class. But that's not all. Being immutable, records still provide us a huge flexibility of adding the customized constructors, methods, static references, and static methods inside the record class. Let's have a look and see how it works. Let's create a customized constructor where we check that the x and y coordinates are greater than 0. For example, in my coordinate net, there is no negative coordinates at all. So we are checking if the x coordinate is less than 0 or y coordinate is less than 0, and then I throw the illegal argument exception. And that's it. As you can see, I'm not typing here like this x equals x, because this is redundant. This is done automatically out of the box by the record type declaration. So in the constructor, we only need to declare our additional checks or additional logic, and all the initialization will be done afterwards. And yeah, let's check it, why not? I want to create, for example, the point record 4 that will have the -10 and 20. And I will execute the code and see if I will be able to. As expected, we have an exception, a legal argument exception, and we are not allowed anymore to create records with their negative values. That's great. And I want to add a custom method inside the record that will calculate the distance from origin. And for that, I just declare a new method, as we do for any other Java class. Public distance from origin, and I'm returning the math squared x multiplied x times plus y multiplied y. And that's it. We have this method that is returning the distance from origin. And again, let's have a look and check. I will comment out this our non-working point. For example, point record 1, distance from origin, and check that it works. And it actually does. It has some calculations inside, and so you can extend the functionality of the record as much as you want. For records, we can also add the static fields and the static methods. For example, let's go with the public static final integer and name it coordinate start. That will be equal to 0. And I will also add the static method that will create the point record in the start of the coordinate net. And I will call it some origin. And I'm returning the new point record in the coordinate start. And yeah, let's have a look again. And I want to system out println this record and verify that the coordinates will be 0 and 0, just as expected. To showcase the immutability, I will try to add the extends keyword here. Extends, for example, point. See, I have the extends clause not allowed for a record. And the same goes, for example, if I create the new Java class, like another point, and I will try to extend the point record, and I'm not allowed to because it is final and it cannot be extended. But at the same time, I can implement as many interfaces as I want. And for example, I want to make it serializable, and here we go. It's allowed to, and I can add, for example, runnable, and thus I need to override the run methods. It's possible. You see, there is no error at all. Well, when I'm talking about out of the box, it sounds cryptical and magical. And frankly speaking, I don't like it because programming is quite accurate and precise science, and you can explain everything from the very beginning to the machine code compilation. And I would love to show you how this out-of-the-box magic works. First of all, we will go and see our generated class file, point record. By examining this file, we already see how it works. We see in this constructor that the x and y parameters are initialized. So this is done on the compiling step, and this is added to the class file. We can see the getters here as well. So the getters are added on the compiling stage to the class file. And this looks quite familiar, right? But one may ask, where are the equals, hashCode, and toString methods? A good question, I will answer. Let's see, because it's a bit more difficult, but much more efficient than just generating this in a bytecode. In the case of records, methods like equals, hashCode, and toString are generated as synthetic methods. And a synthetic method is one of those that is not explicitly defined in the source code, but rather generated by the compiler. And these synthetic methods are handled internally by the JVM. And when the JVM encounters a call to one of these methods on a record instance, it knows how to handle them without needing an explicit definition in the bytecode. The JVM uses method handles and the other mechanism to invoke the correct implementation. We can see in the Java library, in the record class, it should be in the Java lang, and the record class, we can see that it has the override of these methods of the object class, equals, hashCode, and toString, which exactly is this synthetic implementation I just talked about. Now, the magic happens inside the invocation of these methods dynamically. Let me show you. Let's call the Java P with a verbose flag and see what is exactly inside the bytecode of the record class. Here is our instructions for JVM. This is actually the bytecode. And if we check the invoke dynamic, we will see these references for toString, for hashCode, and for equals. And while invoking dynamically these methods inside the runtime, the representation of these methods is called, and actually there is only one representation that has to be done. It takes into account only parameters of the record. Everything else is absolutely the same, and thus it has not been written anywhere in the code, not to duplicate it and make it more efficient for JVM. Unfortunately, you will not see in the bytecode that, for example, x and y coordinates are sent to those methods, because the invoke dynamic instruction operates differently than the traditional methods and calls in the bytecode. It does not bind to a specific method implementation at the compile time. Instead, it defers the method linkage to runtime. The linkage logic is encapsulated within a bootstrap method, which is a part of the Java language runtime. I hope it's not too complicated, and now you understand how this out-of-the-box magic works, and it's not actually the magic, but very precise instructions for the Java virtual machine. And by the way, the dynamic invocation was added in the 7th Java version to be able to support the next huge update in Java 8. All the lambdas and functional programming part of Java relies on this heavily. So records are reusing a very nice feature that changed the landscape of the Java programming language. Now you know how the record works and how to use it. Now let's recap. With just one line of the code, Java record implements getters, constructor, equals, hashCode, and toString methods. Java records are immutable, and that means that they cannot be extended and they cannot extend any classes. But they can implement any interfaces and as many as you want. Java records are best being data transfer objects, known as DTOs. They're also great being API response objects carrying your immutable data to its destination. They also can be great at having the immutable configuration object, if your configuration does not change during the runtime. And they are also irreplaceable for being event objects, carrying the immutable events and saving the boilerplate code. Thanks for watching this video. I hope you enjoyed it and learned something new about Java records. Until next time, keep coding, innovating, and never stop learning and exploring the Java world.